Welcome back. See, consider an equality a plus 1 into a plus 2 equal to a squared plus 3a plus 2. You consider this equality, okay? You write it down. A plus 1 into a plus 2 equal to a squared plus 3a plus 2. Right? A is a variable. So, whichever comes on to the left hand side of the equality, the expression that comes to the left side of the equality, okay, when we are seeing it, whatever you find onto your left side of the equality is called as LHS, which is nothing but left hand side, okay. And whatever you see onto the right side of an equality, you call it as RHS, which is right hand side, okay. So you will keep coming across this LHS and RHS repeatedly while solving mathematical problems or while going through examples. So this represents, when you see onto the notebook, whatever you see onto the left hand side of your equality, you are seeing it, whatever you see onto your left hand side, right? They are called as LHS, left hand side, okay, of the equality. And what you find onto the right hand side, we call it as RHS, which is right hand side of the equality. Now in this specific equality that I had given, expression that I have given, I am saying a plus 1 into a plus 2, right, equal to a squared plus 3a plus 2. Which one is LHS? It is a plus 1 into a plus 2. That is the left hand side of the equality, okay. And which one is RHS? The other expression, a squared plus 3a plus 2 is the RHS. Now you apply any value for a. You substitute for a any value, say 7 or 8 or 9 or 10, whichever value comes to your mind. Substitute for a onto the left hand side. So let me substitute 5. So what do you have on the left hand side? A plus 1 into a plus 2. So I am substituting 5 for a. So what do we get? 5 plus 1 into 5 plus 2, which is nothing but 5 plus 1 is 6, 5 plus 2 is 7, 7 into 6 is 42. Okay. So LHS is equal to 42. Now substitute the same value onto your right hand side. A squared is nothing but a into a. So I have a as 5. 5 times 5 is how much? 25. Plus 3a, 3 into 5, 15. Plus 2, right? So 25 plus 15 is 40. 40 plus 2 is 42. So RHS is also 42. So you have LHS equal to 42, RHS equal to 42 when you substitute for a the value 5. Similarly, let us check the equality for one more value of a. Let us take 3. So what would be the value of LHS? 3 plus 1 into 3 plus 2, which is 20. What will be the value for RHS? A squared is nothing but 3 into 3, 9, plus 3a, which is 3 into 3 again, 9, 9 plus 9, 18, plus 2 is again 20. So LHS is equal to RHS. So you can check, you can verify for any value of a, LHS will be equal to RHS. Or in other words, the equality holds good. Such an equality, right? The equality of the nature that we had talked about, a plus 1 into a plus 2 is equal to a squared plus 3a plus to such equalities that is true for any value of A is called an identity. So for any value of A, such equalities that satisfies the equality condition is called an identity. So there are certain common identities which we will have to remember. Okay. You find out what is A plus B into A plus B. Right? So A plus B into A plus B is nothing but multiplying a binomial with another binomial. Right? I wouldn't say another binomial, with the same binomial. A plus B, we are multiplying it with itself. Okay? A plus B into A plus B. Now, how do we multiply it? So, left hand side, A plus B into A plus B equal to A into A plus B. Right? Plus B into A plus B. So, you will find A into A plus B is nothing but A into A, which is A squared, plus A into B, which is AB. Plus B into A plus B. B into A is BA, plus B into B is B squared. Right? So you have A squared plus AB plus BA plus B squared. Now B into A, BA can be written as AB, isn't it? Commutative property. So you write as AB. So A squared plus AB plus AB plus B squared. So you get A squared plus 2AB plus B squared. Again, this equality will hold true for any value of A. This is a very important identity which you have to remember. A plus B into A plus B, which is nothing but A plus B the whole square. Okay. The square of any number is multiplying that number with itself. Okay. So A plus B into A plus B is nothing but A plus B the whole square equal to A squared plus 2AB plus B squared. Similarly, you find out what value you get for A minus B into A minus B, which is nothing but A minus B the whole square. Okay. So A minus B into A minus B equal to A into A minus B, right, minus B into A minus B. So A into A minus B will yield you A squared minus AB, minus B into A minus B will give you minus BA plus B square. Okay, minus B into minus B becomes plus B square. So you get A squared minus AB minus BA plus B squared. Now minus BA can be written as minus AB. Right? Commutative property. So A squared minus AB plus B squared, which is nothing but A squared minus 2AB plus B squared. This is another important identity. A minus B the whole square equal to A squared minus 2AB plus B squared. Now you find out what is A plus B into A minus B. A plus B into A minus B. See, all these identities will be of great help when you start solving exercises. Right? When you have to find the answer to a particular problem by applying identities, your problem becomes simplified. So that is why these identities are very important. These are very, very useful. So A plus B into A minus B equal to A into A minus B plus B into A minus B. Okay. A plus B into A minus B equal to A into A minus B plus B into A minus B. So which is nothing but you have A into A squared minus AB plus B into A, BA minus B squared. So BA can be written as AB. Okay. So A squared minus AB plus AB minus B squared. So your minus AB plus AB becomes 0. Right? Minus AB is the additive inverse of AB. So it becomes 0. You get the answer A squared minus B squared. So A plus B into A minus B equal to A squared minus B squared. Okay. Or in other words, conversely, A squared minus B squared equal to A plus B into A minus B. See, you might ask, where do we use all these things? See, let me give you an example. I am asking you to find what is 102 square, 102 square. One option that you have is you write 102 multiplied by 102, multiply it and find out. I am saying you don't multiply it, but using identities, if you have to find, how will you find? 102 can be written as 100 plus 2. So I have already told you identity will hold good for any value of a and b, right? So 102 can be written as 100 plus 2. 100 plus 2 the whole square, which is what 102 square is. It is of the form a plus b the whole square, isn't it? So now you apply the identity. A plus b the whole squared is equal to a squared plus 2ab plus b squared. So here instead of a you have 100. So you find 100 square plus 2 into 100 into 2 plus 2 squared, which is 4. 2 into 100 into 2 is how much? 400. 100 squared, you know, you put 1. In 100 there are 2 zeros. So in its square you will have 4 zeros. Now you add all these 3 numbers, you will get the answer. Similarly, if you have to find out 98 square, so instead of 100 plus 2 the whole square, you put 100 minus 2 the whole square, which is a squared minus 2ab plus b squared. Substitute the values, you will get the answer. So if somebody wants you to find out 102 multiplied by 98. So what is 102? It is 100 plus 2. What is 98? It is 100 minus 2. So 100 plus 2 into 100 minus 2. What is it? 100 square minus 2 square. See, becomes easier. You need not have to, multiply, because this multiplication can be a slightly, larger multiplication, longer multiplication. You need not have to multiply. You can apply the identities. So that will make your job easier. So there is also one useful identity that you have, which is x plus a into x plus b, where a and b are numbers, x is the variable, okay? X plus a into x plus b. This can be written as equal to x squared plus a plus b into x plus ab. This identity also you have to keep in mind. X squared plus a plus b into x plus ab. Okay. So these identities will be of great help when you start going through the exercises. So these identities are very, very helpful. So you will have to be thorough with these identities. So we said a plus b the whole squared equal to a squared plus 2ab plus b squared. A minus b the whole squared equal to a squared minus 2ab plus b squared. A plus b into a minus b equal to a squared minus b squared. X plus a into x plus b equal to x squared plus a plus b into x plus a into b, ab. Okay. Please remember these identities. Alright. So in our next video, we will run through the exercises. I will give you certain hints about the exercises. And with this, we have come to the conclusion of our second chapter, which is nothing but chapter 9 in your NCERT book. That is called as Algebraic Expressions and Identities. To sum up, we had learnt about what an algebraic expression is. We had learnt about terms, coefficients, factors. We had seen how to identify like terms. So we had studied about like terms and unlike terms. We had learnt about monomial, binomial, trinomial, and in general polynomial. We had seen multiplications between monomial, binomial, trinomial, or in general polynomial. And we had learnt about useful identities, important identities. Okay. So good luck. I hope you would have found these lessons useful. In case if you have any doubts, you know how to ask, you will write an email to askmentorguru@gmail.com. askmentorguru@gmail.com. Okay. Thank you.